Okay, so now in this next set of problems, we're going to find the value of x and or y that would make the two triangles similar, then determine by which theorem or postulate would prove them to be similar. So what do I mean by that? Well, we got these two triangles right here. I'm going to say this corresponds to that, and that corresponds to that. All right, so I'm going to very carefully say, well, 3 relates to 6, 5 relates to 3x plus 1. All right, again, when I have a lot of junk, I like to put parentheses before I cross multiply. Thus, when I do cross multiply, I can ensure I'm going to keep my work organized. All right, because I can remember, well, I got to distribute. We're going to have 9x equals 27. Divide both sides by 9. And x equals 3. All right, so what does this really mean? Well, if I plug in really fast, if I plugged in, I'd have 10. Sides are proportional. Now, how do I know these two triangles are similar? Well, these angles right here are congruent because they're vertical angles. Remember, vertical angles, to put it in simple terms, are opposite angles on x. Okay, so that's vertical angles. So these two triangles are similar by side angle side. We have two sides that are proportional. We have an included angle. So x equals 3. Triangle is proportional by side angle side. All right. This next one's goofy. It's hard to tell what's going on, all right? I'm going to say, well, 9 and 12. What happens if I say those are corresponding? And let's just focus on, I guess, y first, all right? So I can say 12 and 9 relate. And then I can say, well, then 18 and 3y plus 3. All right, and it's important, like I said before, put parentheses around this junk. So when I cross multiply, I can keep my work organized and try to eliminate silly mistakes. And then 9 times 18, I believe, is 162. Distribute, I'm going to get 36y plus 36 equals 162. Subtract 36 from both sides. Got 36y equals 126. Divide both sides by 36. And we get a fraction this time. Nothing wrong with fractions, but we get 3.5 is y. All right. Now, we can do the same thing, but this time we're going to solve for x. This one's a little bit of a challenge problem. I have to deal with some decimals, got multiple things going on. But the setup's going to look quite similar, where I got 12 over 9. And that's going to equal 5x minus 2 over 21. And again, let me put parentheses around my stuff. Then I'm going to cross multiply. Get 252 equals 9 parentheses 5x minus 2. Then I'm going to distribute. I'm going to get 252 equals 45x minus 18. Add 18 to both sides. 270 equals 45x. Divide both sides by 45. And 6 equals x. All right, so somewhat of a challenge problem, a lot of problems going on. So in these two, x is 6 and y is 3.5, it's going to force these triangles to be similar by side, because all I have is sides, no angles. All right. This next one right here, what's going on? Well, let's do y first. Y and 18 correspond. And 10. And this length right here is, we got to realize this length is 12. All right, because we did 10 plus 2, so this whole thing is 12. So what I can say is, well, 12 relates to 10, and 12 is the longer length, 10 is the smaller length. Well, y is longer than 18, so y will be on top over 18. And then from here, just cross multiply. What's 12 times 18, you wonder? 216, so 10y equals 216, divide both sides by 10, and y equals 21.6. So a lot of decimals going on right now, that's not a big deal. All right. Next, we got to do x. So this is a little foreshadowing. We could also set it up like this, where we look at 10 and 2, and we look at 15 and x. All right, so we don't have to get too fancy. We can just look at it like that. Again, I got a lot going on here. So I can say, well, 10 to 2 is the same as 15 to x, because with this triangle we're given, and then the small sliver, just relate it to the same way. And then cross multiply, you get 10x equals 30. Divide both sides by 10, x equals 3. And again, all we have is side lengths, so y is this value, x is that value. Well, these two triangles must be similar by s, s, s. Again, not very organized with my work right now, but nonetheless, it's all right there. You can always pause to organize it a little bit better than I did and then catch back up. But anyways, cruising right along. This next one is a doozy. We actually have 3 triangles going on right here. In fact, we talked about something similar to this, pun intended, yesterday. But notice how we have triangle GFD. Triangle GFD. This is a right angle. And then what else do we have? Well, let's talk about the big one. Notice how we have triangle, that's supposed to be an E right there, kind of got cut off. Then we have triangle GDE. All right, so we have a right angle, and we have angle G in both of these, and a right angle. So in the purple one and the orange one, they both have angle G and a right angle. So I'm going to say squiggly line similar by angle angle. Next, what do we got going on here? We got this green triangle. So this green triangle is triangle DFE. And F is a right angle. And notice how they both have angle E. So angle E, angle E. This orange triangle, this green triangle, they both have a right angle and angle E. So those two triangles are similar by angle angle, similar by angle angle. And then, in fact, all the triangles are similar to each other by angle angle. And that's a transitivity property of angle angle, or of similar triangles. All right.